So next we're going to talk about arithmetic sequences. So an arithmetic sequence is an ordered list of numbers such that the difference between the consecutive terms is constant. So for example, the sequence 7, 9, 11, 13, it's arithmetic because what we call the common difference, the separation between them, is 2. So basically I'm just saying I'm adding 2 every time. I'm adding the same number every time. That makes it arithmetic. So here, this common difference is 7 because I'm adding 7, adding 7, adding 7. So this is an arithmetic sequence. Here I'm adding 6 every time. Here I'm subtracting 5. Remember, subtracting 5 is the same as adding -5. So this is still arithmetic because I'm subtracting 5. So here I'm increasing by 4 on this one, plus 4 plus 4. This one I'm adding -3. So I'm actually dropping by 3, but it's still arithmetic. This one here, I'm just adding 4 every time, plus 4, plus 4, plus 4, so it's arithmetic. Now what we want to be able to do is write the general term for this. We want to be able to write a formula that will tell me any value anywhere along the sequence. So we're going to use this common difference as a tool for us, and we're going to use the variable d, d for difference. So consider the example below to write this term formula. I have 4, 7, and 10. And we're going to try to write it as arithmetic, which it is. So 4, 7, 10, 13. Term 1 is 4. That's easy. First term is 4. Simple. The term 2, the second term, the 7, it ends up being 4, my first term, plus 1 addition of 3. So I've added 3. I add 3 once. That's what's happening here. That gives you my 7. So start at 4, add 3 once. Got it. Okay. Term 3 over here, the 10, that's start at 4 and add 3 basically twice. So I start at 4, I add 3 once, I add 3 twice. That gives you my 10. Okay. Term 4, the 13, that is, well, obviously you start at 4, and then I'm just going to add 3 once, 2, 3 times. So add 3 the 3 times. And, after a few steps here, we can look for a pattern, and we say, okay, well, every single time I'm starting at my 4, so I'm going to have my 4 in my formula. I'm always adding 3 every time. It's the same every time, add 3. So add 3 all the way through, got that. And really the separation is, if I want the second term, I've added 3 once, because I do one jump, right? If I want the third term, I have to add 3 twice, so I'm off by 1, and so on. If I want the fourth term, I've added 3 times. So that little separation, we can capture this algebraically. We're going to use a for the first term, okay? We're going to use d, the common difference. And if I'm going for tn, the nth term, this multiplier is just n minus 1. I'm just multiplying by n minus 1, which is kind of cool. So the fourth term basically means I have 3 additions. We don't want it to be 4, right? The fourth term isn't going to be a 4 over here because that would actually overstep. We'd have 1 extra count. So these variables coming from the pattern will give us our formula. That's what it looks like. So our any term is the first term, plus we add to that our common difference, just n minus 1 times. So the 10th term, I start in the first term and I add 9 common differences. So what that looks like, that's right here, like that. So this is the general term of an arithmetic sequence. This is our formula. So we can try one, find the 6th term, 4, 7, 10. It works out to be 19. So of course, we can do the short ones by hand, but we'll use a formula. A is 4, my first term. Common difference is 3, and I want the 6th term. Find the 6th term, so the 6th term. So I plug it in, t subscript 6, 6th term, first value 4, plus 6 minus 1, I have 5 jumps of adding 3. So 6 minus 1 is 5, 5 minus 3 is 15, plus 4 is 19, which is what it works out to be. Now, of course, we could, ask for the 53rd term. We can't do this, but we could do it by hand, but we don't want to. We'll use the formula. So same thing, A is, first term is 5, my common difference is 8. I just look at it and say, okay, I'm adding 8 every time. So we just find that by inspection. And I want the 53rd term. I'm going to plug it in. First term, 53 minus 1 times 8, 416 plus 5, 421 would be the 53rd term. So if I wrote this out all the way down, all the way, the 53rd term the value of it would be 421. Now for this, sometimes the final term is given, and the question is going to be how many terms are there? Okay, so I've given you the very last term, 119. So again, we're going to use the term formula, but in this one, I know A is 3. Okay, so if I go back up, I see A is 3, first term is 3, and I'm adding 2 every time, adding 2. So I've got A is 3, I'm adding 2, and my term, the value of my term is 119. Okay. So I'm going to put in 119 in for the, kind of like the answer. This is like, getting the answer, tell me what the n is. So this is actually okay for us. This is just a linear model, right? There's no squaring or anything, just a linear equation. So we can solve this, right? I'm just going to use distributive property, get rid of the brackets. I'm going to collect like terms here. 3 take away 2 is 1. I'm going to subtract 1 from both sides, and then I'm just going to divide by 2, and that n is 59. So I put in 119, and I got n is 59, which means 119 is the 59th term. So that means. And if 119 is the last term, that means that there are 59 terms in the sequence. Okay, take a look at 385.